Cross multiply, good. Or you can multiply by the reciprocal on each side, which is really the same thing. So I'm taking 6 over here and making it 6y. And I'm doing 15 times 1 1/2. The 1 1/2 I'm going to change to an improper fraction, because when we're multiplying fractions, we can't keep it in mixed number form. We have to have it in improper form. So this is 6y equals 45 over 2. You with me so far? Okay. How do I get the 6 to the other side? Divide it. Dividing by 6 is the same thing as multiplying by its reciprocal. The reason I'm doing that is if I said divided by 6 and this is a fraction, I'm going to end up having to divide two fractions, which is multiplying by its reciprocal anyway. So I'm left with y equals 45 over 12. And you couldn't keep it like that. You had to simplify it by taking a 3 out. So it should be 15 over 4, 4, 3, and 3/4. Did I lose anybody? Any questions?
I multiply each side by 15.
Multiply each side by 15. Okay, that's fine. Oh, right here?
Yeah.
That would be okay, because you're saying 15 and then 15, this would cross out, and you brought it to the other side.
Yeah.
But then what did you do with the 6?
Well, then I got 22.5 over 90, and then that.
All right, let's do it that way and over here. Okay, so she just brought the 15 to the other side, which is perfectly fine. Then you're not going back and forth. This crosses out, and you just have your y. Over here you have 15 times 3/2 over 6. Okay, so you want to simplify this. Then what?
Let them do, or can you do that?
Okay, the problem is when you're doing this, you don't want to start multiplying until you take care of this division. Okay?
I just multiplied by each term. I did 15 times 3 over 2 and then 15 times 6 and over each other. And then I just simplified that. So less than I agree with.
Did you get the right answer?
No.
No, okay. So if you want to multiply it here, it would be 45 over 2, but you still have it over 6. So that's a fraction. So 45 over 2 times 1/6, which becomes 45 twice.
Oh, okay.
See, if you multiply this by the 6, you don't want to do that. It's not in parentheses. This is like a fraction. This is 15 over 1 times the numerator over denominator.
Oh, okay.
Does that help?
Yeah. No, I did.
What other questions? Text. I think the last page, almost everybody got it right. Do which one? Number 18. 18. A equals 1/2 H B plus D. A is 48, B is 3, and D is 5. So you could either isolate H first and then plug in the numbers, or you could plug in the numbers first and then isolate H. If you went ahead and plugged in the numbers, it would be 48 equals 1/2 H B plus D. We got to remember our order of operations. We do parentheses first. This is all being multiplied together. Then we do multiplication. 1/2 times 8 is what? 4. I want H by itself, so I divide both sides by 4, and I get 12. Yes? 20. Okay, so we need to solve this just like it's an equation, keeping our inequality there. So the first thing we want to do is distribute the 4.6. 4.6 times 4 is 18.4. 2.4x minus 7.2 plus 0.9. There was just a lot of room for error with these decimals. Could we have gotten rid of the decimals? We can. You could multiply all of this by what?
10.
10. If you wanted to, you could multiply everything by 10 and you would eliminate your decimals. If you did not want to do that, you can still work it with decimals. Either way should be right. Okay, now we want x by itself. So I'm going to clean this up by combining like terms. And my only like terms are these two right here. And you get negative 6.3. It's tricky because you have a negative that's larger plus a smaller decimal. So you got to remember to subtract them and take the sign of the larger. Okay? So that's 7.2 is bigger than 0.9. Now I'm going to take 2.4 to this side. And I'm going to take 18.4 to this side. When I do this, I get 2.2x is less than 12.1. Has my sign flipped? No, and it's not going to because this is positive. So I'm dividing by a positive number. It does not flip. So x is less than 5.5. Okay, to graph this, is it solid dot or open dot? Open dot, x is always less, so it goes that way. Any questions? Okay, I'll come collect the test then. Good job on them. And before your final, you guys will get all these back to keep and to use to study for your final. I just have a whole lot of doing that semester. Good. Okay, we get to start chapter 3 today. Which is going to be application problems. You guys are late. David.
I'm sorry.
That's okay.
I can't speak for them, but I'm sorry.
Melissa. Okay. I will show you guys your tests, but we've already gone over them. So you can look at them and then I'll collect them. Okay. 3.1 and 3.2 are what we are covering today. And I hope you're awake today, because you need to pay attention. It's the stuff you're going to have to put your thinking caps on. Okay. 3.1 is called Changing Application Problems into Equations. So what this really means is how do we take real life situations, real world problems, and turn them into a mathematical problem. So we're going to learn how to put words into numbers. And sometimes that's the hardest part, is just to get it into a mathematical equation to solve. If you look in your book on page 172, there is a table I want you to look at. Okay, table 3.1 on 172. Rather than writing all this on the board, let's just look at this. Words or phrases that mean to add. Some of them are pretty self-evident, like added to. But words like more than, increased by, and the sum of, those are all indicators to add. Subtracting would be subtracted from, less than, decreased by, the difference between. Multiplication, multiplied by the product of, twice a number, 3 times a number, and the word of. Okay, the word of is a big one. And division, divided by is pretty obvious, but also the quotient of. So when you see those words, it should tell you what operation you're going to perform. Remember that addition and multiplication are commutative. So addition and multiplication are commutative. What does that mean? Is that right? Any order. Any order. However, subtraction is not. So you have to be careful in word problems when you're dealing with subtraction, because the way they say it makes a big difference. If I said 5 less than 3 times a number, how would I write that? 3 times a number minus 5. So it's 5 less than this number. Another way you might see that is 5 subtracted from 3x, 3 times a number. And it would look the same way, right? But if I said, actually this is the same way too, the difference between 3x and 5, it would also look like this. So those are just 3 different ways that mean the same thing. But if I said 3 times a number less 5, would that be, how would I write that? 3 times a number less 5. Yeah, it'd be the same way again. That's just another way to do it. So pay attention, because subtraction order does matter. Addition and multiplication, it doesn't. Five inches less than twice the height. Okay, we let h mean height. How could I write that as an expression?
2h minus 5.
Good, 2h minus 5. Got it. Okay. Expressing the relationship between 2 quantities. If you look at the bottom of 173, this is what I'm going to go over next. This is when we have 2 numbers. We want to represent one of them as x and the other in terms of that number. For an example, if $30 is divided between Zach and Taylor. Okay? So we have $30 and it's going to go to Zach and it's going to go to Taylor. If I give Zach 30, how much is Taylor getting?
0.
If I give Zach 25, how much is Taylor getting?
5.
How about if I give Zach 5, how much is Taylor getting?
25.
Okay, how did we figure that out? We did 30 minus whatever Zach has. So to put this in terms of algebra, we're going to let x be one of them, Zach, and we're going to let 30 minus x be Taylor. That's the way we write this in algebra. You know how to do it when you see it. You just have to put it in algebraic terms. So whatever Zach has, Taylor's going to have the total amount minus that. Whatever Zach has. Okay. You're going to see that kind of thing a lot in word problems. Let's look at another one. How do we determine who gets to be x? Determining the x. If Juan is 3 years older, then 4 times Frida's age. Who are we putting age in terms of? Frida. Frida is what we don't know. Frida is the x. Because Juan is being given to us in terms of Frida. So if Frida is x, then Juan is 4 times Frida plus 3. 4 times Frida's age plus 3. And that is Juan. So in all problems, you want to write your unknown. When you have two different things you're comparing, two quantities, one of them is going to be x and the other will be in terms of x. Does that make sense so far? Yes?
So is x, Frida,
X is Frida because if you read the problem, they don't tell us anything about Frida, like that she's 3 times older or 4 more. They just say Juan is this in terms of Frida.
Okay.
Whatever Frida's age is, Juan is determined from that. So she's just our unknown, and Juan, they tell us everything about whatever she is, it changes him. Kind of like over there. Whatever I give Zach determines what I give Taylor. So Taylor's determined on Zach. It'll become clear the more you do these. Okay, if Mary weighs 15 pounds more than Sue, since Mary's weight is expressed in terms of Sue's weight, then X is who? X is going to be which one? Sue, because we don't know Sue, we just know Mary is going to be 15 more than that. Okay, so Mary is determined on Sue. Let's look at one more. Joe earns $56.20 less than Larry. Who's my X? Larry's the X. He's actually not my X. X is Larry, so what is Joe? X minus 56.20. And there's where that less than comes in too. Would it be right to say 56.20 minus X?
No.
No, totally different problem. So you have to know that it's $56 less than whatever Larry was. So put that subtraction in the right order. All right. Are you with me so far?
I think so.
The theater sold 525 tickets. Some were adult and some were children. Now, in this problem, is either expressed in terms of the other? Is
No.
whatever adult ticket determined on the child? No. So in this case, it doesn't matter who's X. Okay, if one is not reliant on the other, just pick one. Let's make X the adult ticket. So what would the child ticket be?
Why?
No, I think 525 minus X.
Very good.
Oh.
It's like that problem right here. Because I have a total, I have 525. However many were adult, I know the children were that minus the adult. because I only have this many to hand out. So if I handed out X to the adults, the rest are children. So that's exactly like this problem. So nobody has to be the X. It could be either one of them, but the other one is going to be whatever they are minus that. Okay, total minus the first.
This is a division already.
Oh. Very good, maybe. Maybe not. It's not asking us to solve anything. It's just asking us to write an expression. So if a 30-foot board is cut into 2 lengths, select the variable to represent one length and write an expression for the other. Is this kind of like the money problem and the ticket problem? Mm-hmm. It is, because we have a total, and whatever we take off for the first one, the second one is going to be the total minus
You
that.
could put like X equals board 1, and then 30 minus X equals board 2.
Yes, you could say the
Okay.
first board is L, just a length.
Okay.
So what is the second board?
30 minus X.
Yep, so the first board still is L. The second board is 30 minus L. So it's the same as these two. So whenever you have a total of something and you're splitting it 2 ways, this is always going to be how it works. Okay? It could be money, it could be tickets, it can be length, it can be anything. When you're splitting something 2 ways.
But if it said equal parts, it would be a
Yes, if it said equal parts, yes. Then it would. But we don't know how much, right? That's the whole
Right.
thing. We don't know if you took off 1 foot or 29 feet. Let's look at another. Duke scored 12 points more than the Tigers. This goes back to, is one in terms of the other? Yeah. Who should be the unknown? The Tigers. We don't know what Tigers is. But we know Duke is what in relation to Tigers? X plus 12, 12 points more. So whatever Tigers scored, Duke will always be 12 more than that. Okay. And these are all in your book, so just pay attention to what I'm doing and don't worry as much about writing it down, because you can always refer to it again. Okay, an adult robin is 4.3 times the weight of a baby robin. Which one is in terms of the other? Who should be X? The baby. Okay, whatever the baby is, the adult is what? And you notice this time it's times, it's not added. It's 4.3 times more, not 4.3 more. That's the difference. More than is addition, times would be multiplication. Very good. All right, I'm going to put up 3 that I want you to try on your own to see if you're getting this. Don't look in your book, because it's probably in there and I don't want you to cheat.
Can we look at the table?
Yeah.
Okay.
Look at the table. Okay. this is number one. I want you to define the unknowns for me, the expressions of what they each be. Okay, are we ready to go over it? Let's do it. Dana and Scott share $60. Who would like to come up with it? Judy.
X equals, Dana 60 minus X equals 20.
Very good. It's one of the total problems. Does it matter if X was Dana or if it was Scott? No. It doesn't matter who we chose for X. It would just be the other one. So this is a total problem. Kim has 7 more than 5 times Sylvia. Who would like to do that one? Zoe. Right. Who's the X? Sylvia, because we don't know anything about her. Everything's in terms of her. Okay? So you're right with your answer. It's just how you set it up. You know, so X should be Sylvia and Kim should be 5 times plus 7. Okay? And that's going to be important on the test. If you give me just this, you'll get some credit, but you need to demonstrate you can do the unknown to get full credit. You want to do the last one, Melinda? Or do you have a question? Okay.
For that one, the meaning of the video times to it, right, it can be 7.
Correct, yes. 7 plus 5x would be fine, because it's addition. Good question. True. Okay, number 3. Anybody willing to do that one? Shannon?
I put 4x minus 3 foot equals the length of the rectangle.
Very good. And what is x?
X is the variable of the width.
The width,
Yeah.
width, that's what I was looking for.
Oh, okay.
So if everything was in terms of width, that's our unknown. Length is 4x minus 3. Now, if you had just said 4w minus 3, that technically is right also, but we're working on what is our unknown and how do I use it in terms of my expression, okay? All right, good. So now
Okay.
writing expressions
Actually,
involving multiplication, yes.
I have a question,
Uh-huh.
because are we doing equations or expressions?
Expressions.
Okay, so there doesn't have to be an answer, correct?
No, there's no answer.
Okay.
No, because we don't know what the width is.
Okay, but we still, why is it not an equation if there's an equals?
Well, I'm just saying it represents this. I probably shouldn't put equal signs. It's just x is the width.
X
and this
is, okay.
length.
Okay. I just needed to clear that little cloud there.
No, that's okay. And we're getting ready to do equations. We're learning how to write the expressions so then we can build equations to solve. So it's like one step at a time. We need to know how to write the equations. Good question. Okay, now let's write expressions involving multiplication. And we already did one with the baby bird when it was 4 times the baby or whatever. If I said write an expression for mailing Y letters at 44 cents each, how would I write an expression to represent 44 cents? 44 Y, yeah. But it's 44 cents, so I'm going to write it 0.44. Why?
So it's accurate.
Because it's 44 cents, that way I'll know how many dollars it is. So the problem said cents, so it didn't write it as 0.44. But when you're actually trying to figure out, in real life you're getting married, you have 100 invitations, and stamps cost 44 cents each. That's how you would figure that out, right? Okay, let's try it again. The cost of purchasing X number of pens if they're $2 each. I heard it. The cost is just 2 times X, right? $2 per every pen I buy.
Do you not have to use the proper symbolism?
Proper symbolism.
Wouldn't it be the dollar sign in front of the two?
When you're writing an expression, no.
Okay.
The reason the cents had to be is because this is 44 out of 100. It is a decimal. 2 is just a number of dollars. Now in your answer, if I said I had 100 pens, then you would say the cost was $200. So when we get to solving equations, yes, you want to use your units. But as far as setting up the problem, you don't have to write it in the expression.
Okay.
Does that help?
Mm-hmm.
Okay. Okay, that leads us into a commission problem. A 5% commission
Bless you.
on X number of dollars in sales, if you're a salesman. What's an expression to represent that?
See. 5% of X.
Good. And I heard 0.05S for the number of sales. Why did I have to write it 0.05?
Because it's a
Because
percent.
it's 5%. Can I write a percent in an equation or an expression? No. I have to turn that percent sign into a decimal. Because 5% really is telling me it's 5 out of 100. 5 out of 100%. 5 out of 100 is written 0.05. So whenever you see a percent sign, you use it in math, you need to turn it into a decimal. Alright, so the next one. The number of cents in Q quarters. How would I write that? How many cents are in a quarter? 25. So I have 25 cents for every quarter there is. Okay, I don't write 0.25. I know I did up here. The difference being it's asking me for how many cents, So I need to say there's 25 of them in each quarter. Whereas here it already told me cents and I'm looking for a dollar amount. I know that's kind of confusing if you see the difference. Okay. Look at a word problem using this. Tim rented a tractor for 1 day. He paid a delivery fee of $80 and a usage fee of $200 per hour. Write an expression for the total cost when using the tractor for H hours. So what's my unknown? H, yeah, that's what I'm looking for, okay? That's my unknown. Now we have to write an expression that represents this. What is going to be his total cost? Total cost.
200 plus 80.
Good. He's going to pay 200 per hour plus his delivery fee.
Right.
Now, because it's commutative, you could have put 80 plus 200 each. That would be okay too. So he's going to pay 80 regardless, and then $200 an hour. And that is an expression for this problem. Any questions? Okay. 3.1 is a pretty big section.
I have a question.
Okay.
In that last equation,
Uh-huh.
would you not put not greater than 24, H is not greater than 24 hours?
You don't need to. I mean, when you're solving the equation, the last step of solving a problem is to make sure the answer makes sense.
Mm-hmm.
So if you did get 32, then obviously there's not more than 24 hours in a day. Although for H it could be 32. Maybe he used it more than a day. Why would
Except
it have
it
to be?
says he rented it for
Oh,
a
for 1
day.
day, you're
For
right.
1 day.
So in that
Just saying.
problem, if you got something that was not less than 24, you'd know you did something wrong. So you don't have to write that as like something you know, but when you're solving the problem, that would be a good way to check yourself.
Okay.
Okay. Fred's age is 1 less than twice Alice's age. Write an expression for the difference in their ages. So this is 2 parts. The first part is what we've already learned. Who is the unknown that we're working in terms of? Alice. Whatever Alice is determines what Fred is. So tell me what Fred would be. 2x minus 1. Very good. Now that's all we did before, but now we're going to add something to it. Write an expression for the difference in their ages. So I'm going to write 2x minus 1 minus x, the difference in their ages. Are the parentheses necessary?
Yes.
They're not mathematically. If you took them away, it would be the same problem. The reason you get used to putting them in parentheses is to kind of distinguish between your 2 variables. And it will keep you from messing up if the occasion were to be 2x minus 1 this way. Because look how that changes. The negative would have to change the signs in here. So just get in the habit of when you're comparing 2 things to keep them in parentheses to distinguish them. Okay, we'll talk about that a little more in these problems, these next problems. Okay. Find the sum of 3c minus 4 and c plus s. That's pretty easy, right? 3c minus 4, but I'm going to put it in parentheses, and c plus s. So were the parentheses necessary? No, not mathematically in this problem, but it helped to distinguish between the two, and you had to know sum meant to add. Okay, that was a pretty easy one. Let's look at this. How should I write this one?
X plus 2 minus 3. Oh, from, so I need to 3x and
Very good.
5, okay.
I was kind of hoping you would say it that way, just to make that sense. Okay. Which one has to come first? If you're taking from that. Minus. Here's where the parentheses are important. I'll go ahead and put these two. If I had not put the x plus 2 in parentheses, it would have just said minus x plus 2. But I'm subtracting all of this from 3x, so it has to be in parentheses to make this negative be distributed to both terms when I solve it. Does that make sense? 3x doesn't need to be, I'm just trying to get you used to when you're taking two things and adding or subtracting, you keep them separate. It'll keep you from making mistakes on the subtraction part. Okay, which one goes in the front? The 2r plus 3 in parentheses minus r minus 5. Have to be in parentheses on that second one. Okay, very good. Now let's talk about percents. A lot of writing today. Percent. Okay, we already talked about we have to change a percent sign into a decimal by dividing by 100. Okay? So, if I had a problem that said 25% off, means it's off the original cost. So what is the discount? 0.25. Let's let the original cost be C. C. I'm taking 25% of the cost. That's my discount. Now you know from shopping, is that what you're going to pay at the register? No. How do you figure out what you're going to pay at the register? I heard a bunch of different things. What do you have to do with this number that you find?
You subtract it from the original.
You subtract it from the original. So whatever it costs, you take away the discount. So this is what you're going to have to learn to do for any problems that deal with sales tax, sales, anything like that. And we're going to do a couple of these. So this would be the new cost. Okay, is the original minus 25% of that cost. Okay, there's another percent problem. Express the statement of profit P decreased by 15% as an expression. Is it the same kind of problem as this? It is, right? It says decrease by 15%, but 15% of what? Of the profit. So it's the profit decreased by 15% of that profit. What you need to remember with percent is you never write the percent by itself. It's always a percent of something. So I would never write just 0.15, because all you're doing then is just taking away 0.15 of something. When it's a percent, it has to be taken of some amount. Okay, so percents are with something, and you take them away from the original. But sometimes you add them. And here's an example where you would add it. The cost of a pair of boots C is the cost, increased by 6%. So in this one, I'm not subtracting, I'm adding. I'm taking the cost of the boots, and there was an increase of 6%. Can I write just 0.06? No, percents have to go with something. So it's 6% of the cost. So they marked up the sale of the boots. So it's similar to the decrease or discount, except you're adding. Same idea. The population of a town, P, decreased 12%. How should I represent this?
12.
Very good. P is the population, and it decreased by 0.12 P. So I turned the percent into a decimal, and the percent has to go with something. Okay. Sales tax. Okay, same kind of problem. If the sales tax is 6%, what's the total cost? We'll make cost C.
Plus 6.
There you go. C. All right. You got the hang of it then. Okay. What if I ask for what is 7.5% sales tax on D dollars? How do I represent that?
0.75.
Not 0.075, because this would be like 7.5, and when you move your decimal over twice,
Sorry.
be like this, okay? So good, 0.075 D. Now you notice I'm not adding anything. So I didn't ask for total cost, I just asked for the sales tax. That's different than if I say, what is the cost with 7.5% tax? Do you see the difference? Sometimes in a problem, they'll just ask for the tax. Sometimes they'll ask for the total cost. If they ask for the total cost, it would be C plus 0.075C. And I'm going to change this to C just not to confuse you, because it's the same. Okay, so in one, I'm just looking for the tax, and the other for the cost, I'm adding the tax to the original amount. Okay, now we learned expressions. Guess what we're going to turn them into now? Equations. Because the whole point in all this is to get an equation so you can solve for an answer. What does the word is mean in math? Equal equals. What does the word of mean? Multiply. Okay. Just a little reminder before we start. 5 more than twice a number is 4. When I add this word is, I'm turning it into an equation because you're setting an expression equal to something. So this would be 5 more than twice a number is 4. And after you write an equation, go back and read it to yourself to see if it makes sense. Okay? How about a number decreased by 4 is 3 more than twice the number. Okay, let's take this one at a time. A number decreased by 4. Let's just take that. How would I write that? Okay, a number decreased by 4 is equal sign. 3 more than twice the number. 3 more than twice the number. Okay? So now we have two sides. So we have an equation. You want to try some on your own? What we get?
Do we solve them after that, or do we just leave them like that?
Right now, let's just set them up. Eventually, we'll solve them, but right now, I just
What
want
is,
you to.
is that the sum of the number and the number increased by 4?
The sum of a number and, yeah, that's an and the number increased by 4 is 60. So try that one. I'll write another one over here. Remember, no solving, just set it up. Okay, give those a shot. okay if you don't get it, I'll help you walk through it. Are you ready? Still working. Okay, we'll start. It's okay if you're not done. Okay, Melody, can you help me with this one? Sure. What do you have? The sum of a number and the number increased by 4 is 60.
First I did is equal 60, the sum of it.
That's great, it is 60.
Now that I look at it,
Okay,
I originally got 4 plus x,
well, it's the sum of a number,
so that would be plus x, right?
that's just x. The sum of a number, and sum means to add, okay? The sum of a number and the number increased by 4. Good. You don't have to have it in parentheses, but this helps you see it. So it's the sum of a number, and that number increased by 4 is 60. Okay. Any questions on that one? Michelle.
I got x for the number.
Okay.
What's the number?
Good.
So I got 3x minus 6 equals 1/4.
Is 1/4 x. Very good. That one's a little different because it had a fraction in it. We haven't seen that before. So 6 less, always read it back to yourself. 6 less than 3 times a number is 1/4 that number. Very good. All right, next one, Carolyn.
$2.20 p.
Okay, so 2.20p. Do I need the dollar sign? No. Okay.
Is 22.
Good.
So equal.
It is 22. So I'm taking $2.20 per pen, and it's going to be equal to $22. Very good. Sarah, the number of cents in D dimes is 120.
We did 0.1.
Good. That's a good guess. It is just 10, not the 0.10. Because of the quarter question, and these cent ones, it's kind of hard to decide sometimes. But if it's looking for the number of cents, you want to say there's 10 cents in a dime, not its value, not that it's 0.1 of a dollar. You want to say there's 10 pennies in a dime. So 10 cents per dime is 120. That's good. And David. Good. And you can leave out the dollar signs until you solve your problem. So $4.20 per gallon of gas times however many gallons is 35.20. I'm kind of surprised when they wrote this book they knew gas is going to be that high. All right, very good. So let's keep working. I think that was much better than me sitting up here writing all of them. I like that you guys have got to try them. Okay, let's think of some other words that might be used instead of the word is that would mean equal. So we know is means equal. What else could it maybe say?
Equivalent.
Equates to. Did I hear another one?
Equivalent.
Equivalent. How about will be? The sum will be whatever. Was. Yields. Gives. Those are the ones I have. There might be others. But anything in the terminology that makes you think it's going to be equal to something, okay? Those are just some different verbiage. And here's an example of using one of those. When 4 is added to a number, the sum will be, here's our key word, 20. So when 4 is added to a number, the sum will be 20. one, 6 less than 3 times the other, their sum is 22. What is my unknown?
The number.
Just the number, which is like x, right? So that's one number. What's the other number?
6 3.
If one number is x, the other one is 3x minus 6. Good. Their sum is 22. So I have to add these to give me 22. Now, why do I write it down? Why do I write down the unknowns for each one? Yeah, because a lot of times a student on this test might just give me the 3x minus 6. You forget that you're having to sum it with something. When you realize that there's two numbers you're adding together, it helps you not to make mistakes. Okay, so if there's two things you're comparing, always write down what one is and what the other is. All right, now this is almost the end of 3-1. You have to talk about consecutive integers. What do you think a consecutive integer is?
1, right?
Yeah, so if I said what's the consecutive integer to 2, it would be 3. Good. How do I represent that in algebra? Consecutive integers. X is an integer. X plus 1 is the consecutive integer. Okay, so x would be any number, and the consecutive integer would be x plus 1. But what if I said, if y is an even integer, then what is the next even integer? Good. Y plus 2 is next. Okay, let's do the same thing with odd. Odd integer. Would it be any different than even? No, because it's still every other. So in a word problem, there's lots like this in your homework and will be on the test. If it says consecutive integer, it's x plus 1. If it's even, it'd be x plus 2 or y plus 2, and if it's odd, it'd be y plus 2.
Why would it be y plus 2?
Because think of an odd number, any number you put in here. 3, right? The next odd number would be 2 more than that. You know what I'm saying? So 1, skip 1, 3, skip 1, 5. It's every other is even, every other is odd. So for even or odd, it's always going to be add 2.
So what is it one for the total number, like 775, like 2 numbers, like 2 consecutive integers equal this number?
Maybe. Yeah. Yes, I think that's exactly what we'll have, actually. Something just like that. Okay. Translating words into an equation. And are we solving it or still not solving it? Okay, we need to translate this into an equation. What two things are we comparing? Two cars. Okay, so we've got car 1 and car 2. Which one is in terms of the other?
Car 1.
Okay, so one of them can be x and the other one is in terms of that. So So let's make car 1 be x. If car 1 is x, then car 2 is what? 3x plus 6. Very good. We found our two unknowns. Now, we have to find the total distance traveled by both of them, and it's equal, because it says is, 650. So what am I going to do with these two numbers? Add them. So the sum, or the total of both of them is 650. So that way I can find out how far each one went. Okay, because when I solve this equation, I'll get a number for x. X will tell me how far car 1 went. I plug it in here to find out how far car 2 went. The two of them together should add the what? 650. Very good. Does that make sense to you? How we set up this problem? I'm not getting resounding answers. Okay. Here's another one to try. Mary has $1 more than 4 times the amount of money John has. The difference in the amount of money is $17. Okay, who are we comparing? Mary and John. Which one is in terms of the other?
Mary is in terms of John.
Good. So John is x, Mary is 4x plus 1. Good. So I found my two unknowns. Now I have to look at the next part. The difference in the amount of money is 17. This, when it has to do with subtraction, it's tricky because it matters the order you put them in. Which one should I take from the other? Which one do you think would be bigger?
John.
No,
Mary's
Mary
is-
has to be bigger because she's 4 times whatever he is. So Mary has to be first, minus John, and their difference is 17. When you're doing addition, it doesn't matter which one you put in which order. But for subtraction, you have to make sure you do it right. Because if I had done this, that would have been wrong. Yeah, you would have got a negative answer. Okay? Ooh, good. Last part of 3.1. Ursula, GPA, increased by 8.2%. Her new GPA is 3.4. Okay, so what are we comparing? Old and new. Her old GPA and her new GPA. Her old GPA is X, her new GPA is what?
3.4.
No, plus
0.1.
Oh, X plus
plus
8.0.
0.082 X. Remember when we did those, the percent ones?
But it says her new GPA is 3.4.
What, that's
Equals.
the next part. Right now we're just finding old and new.
Oh.
Then we're going to know that they are, her new is 3.4, okay? But we had to get this down first. Does this make sense when it's a percent problem? You're taking the old and you're doing a percent of it to add on. Okay, this time we're not adding them, we're not subtracting them. It's just saying her new one is 3.4. So I'm not going to add old GPA, I'm not going to subtract it. I'm just saying the new GPA is this. We just wrote down the old to clarify that that was X and to use it to find what the new GPA will be. All right, that's the end of 3.1. All right. Please do your homework so you don't get behind, okay? We're not done yet, we're still doing 3.2. Can't leave. You can get up and stretch if you want. You want a break? Huh?
I said, I was dozing.
Oh. Get up and stretch, go get some water or whatever if you want, but I'm gonna start 3.2. This one isn't quite as long. Okay, all that was about setting up problems. This is going to be about actually solving them. Okay? So we learned how to set them up, now we're going to solve. You don't have to write all this down, but I want you to know the 5 steps to problem solving. Because the school is very adamant about on your tests and on your finals showing your steps of how to solve a problem. Okay? So when I grade, I look at these 5 steps to see if you've done them. The first step is to understand. That I can't grade. Understand the problem. So what this really means, what does understand the problem mean? It means read it and read again. So before you even attempt the problem, read through it, and then read through it a second time. Okay? Understand what it's saying. 2, translate the problem into math language. Expressions or equations. What we just did, basically. We're taking words and turning them into math. 3 would be to carry out calculations. Or just solve it. 3 is to just solve the problem. 4 is to check your answer. Check it for any mistakes, plug it back in. And 5 is probably the most important. Answer the question asked. Make sure it makes sense. Because a lot of times students can set up the right problem, solve for it, but if they haven't read closely to what it's asking for, you get it wrong. For example, in the sales tax problem, if it just asks for sales tax, make sure you're just giving it the tax, not the total cost. So make sure you're answering specifically what the question asked you to answer. And also make sure it makes sense, like Shannon brought up the hour problem. If it said 1 day and you got hours being 40, you know you did something wrong. So make sure it makes sense. Okay. The first kind of problem we're going to look at is called the unknown number. And here's an example. 4 subtracted from 3 times a number is 11. Find the number. Okay, so this isn't very different from what we've already done today. The only difference is it wants us to solve it. So 4 subtracted from 3 times a number. 4 subtracted from 3 times a number is 11. Let's reread it and make sure we wrote it right. 4 subtracted from 3 times a number is 11. Now I'm going to carry out my calculations to solve. X equals 5. Let's make sure. Check my answer. I'm going to plug 5 back in. Is 15 minus 4 11? Yes. And I'm going to make sure I answer the question. It asked me to find the number. I found the number. That one's pretty easy. Here's another number problem. Okay, and this one I'm comparing two things. When I'm comparing two things, I need to write down what each of them are. What two things am I comparing? So they're a larger number and a smaller number. Those are my two things, right? So larger number and a smaller number. Okay, which one is in terms of the other?
The larger is determined by
Larger is determined by the smaller. So smaller is going to be my x because I don't know anything else about it. But the large one is 2 less than 4 times. Are you with me so far? So I've got the larger number, the smaller number. Now I need to know the difference of the two numbers is 16. Hey, remember I told you in subtraction, order matters. So which one should go first?
the larger.
The larger. We want to take from that. So 4x minus 2, the difference between the two numbers is 16. Okay, so make sure we did that right. The difference of two numbers, we found the larger, the smaller is 16. Now what's my next step? I wrote it in mathematical language, so I solve. 4x minus 2 minus x is 16. Combine like terms. Move my 2 over. Divide by 3 and x is 6. Okay, I found an answer. I need to check my answer. I put it in here. 6 times 4 is 24, minus 2 is 22, minus 6 is 22 minus 6, 16. Yes, I checked my answer. Finally, have I answered the question asked? What was the question asked?
What
What are the two numbers? If I just give this, have I answered the question? No, all I've found right now is the smaller number. What is the larger number? 22. So you have to make sure you're answering the question. My two numbers are 6 and 22. Okay, very good. And the difference between them is 16, so we've done it right. You're doing good, hang in. Carol is older than Liz. Carol is 4 years older than 3 times Liz's age. The difference between Carol and Liz is 10 years. Determined Liz's age. Okay, what two things are we comparing? Carol and Liz. Which one is in terms of the other? Carol's in terms of Liz. So Liz is my unknown. Carol is 4 years older than 3 times Liz. 4 years older than 3 times Liz. The difference between them is 10. When I'm taking the difference, which one should go in the front?
The larger one.
The larger one. Who's larger here?
Carol.
Carol. So 3x plus 4 minus Liz is 10. So I've set up my equation. Now I need to solve. And I get 2x plus 4 equals 10. 2x equals 6. X equals 3. Are you okay with me skipping here instead of writing minus 4
Yeah.
and dividing by 2? I'm not losing anybody? Okay, let's see if we answered our question. Determine Liz's age. Did I determine Liz's age? I did. What is it? 3. 3 years old. This is where your units are important. Did the question care how old Carol was? No, I don't need to find that. But you need to pay close attention because it could have easily said determine Carol's age. If it had said Carol, 3 would not be right. I'd have to put 3 back in and say 13. Okay, so pay attention to what the question's asking. Okay, looks like 2 more columns. Okay, let's start out with our unknowns. Or actually, the first step is to understand the problem, so let's read it. A company presently has a cash reserve of $30,000. It plans to add $2,500 a month to the reserve until it reaches $55,000. How long will it take for the company to reach its goal? So what am I looking for? The months, that's my unknown, M. Months. Very good. Now I have to set up the equation. I'm starting with 30,000 and I'm adding what? 2,500 a month. Until when? Until it reaches 55,000. So that is going to be what my equal to is. I'm looking for how many months until I equal this amount. Does how we set it up make sense? Okay. Next I need to solve. So I'm going to subtract the 30,000 over here and I get 2,500 M is 25,000. I divide 25,000 by 2,500 and I get 10 months. Let's reread the question. How long will it take the company to reach its goal? Have I answered that question? 10 months. Very good. Okay, here's a money problem. And we did one similar to this with the tractor. Maybe I'll let you try this one on your own, since we've done one similar. Okay, when solving this problem, I want you to show me your unknowns. Over here, I didn't do a good job of that other than M was months, but I also wanted to put in, how would I say that, I guess, best? Increase. 2,500 M was the increase, okay? So when you solve this problem, I want you to tell me what we're looking for. What is the unknown?
We're looking
And
for
then
the
solve
mileage.
problem.
We're looking for the mileage.
We're looking for mileage. So you can make that equal to MX, whatever you want it to be. Okay, we solved the first one. Somebody want to tell me how they did it? Okay, did you use M for miles?
Yes.
Okay. What is my equation? $42 plus 24 cents a mile. Why do I have to put 0.24 in this problem? Because we're doing dollars and cents. Very good. Is 63.60. Because in this problem I have a dollar figure. I have dollars and cents. So 24 cents I need to write as a decimal as well. That's important. When I solve this problem, I'll end up getting M equal to 90 miles. Have I answered the question? Yes, so 90 miles were driven. The hardest part is setting up the equation and realizing 24 cents had to be written as a decimal. The next problem over here. The cost of trash pickup is $49 plus 30 cents a pound for waste management. The cost for Sun City disposal is $89 plus 10 cents a pound. And this is different. We haven't done a problem like this. How many pounds need to be picked up to make the cost even? So this time I'm not looking for, they're not giving me a dollar amount and saying how many pounds to make it this much cost. It's wanting to know when they're even. How do you find out if something's even?
You set up like a one side of it.
You set them equal to each other. Exactly right. So let's figure out what Waste Management is and Sun City, because those are our two companies. Waste Management is $49 plus 30 cents a pound. Again, I had to write cents as a decimal because we're dealing with dollars. Sun City is 89 plus 10 cents a pound. So I wrote down my two unknowns. Now I have to write my equation. When are they going to be even? Well, what I need to do in this problem is set them equal to each other. Okay, we have not done one like that. You have to set them equal to each other and solve for P. When you do solve for P, I'm not going to work out the math in interest of time right now. 200 pounds is what you get. So at 200 pounds, these two companies would be equal.
equal in payment.
Okay? You could also do a problem with that and say which one is the better deal, you know, by putting in different pounds. But that's not what it asked in this specific problem. All right, lastly, I'm on my last page, guys. Set up and solving application problems with percents. Remember, percents have to be written as decimals. The cost of a meal and a 7% tax is $16.26. Find the cost of the meal before tax. Okay, what I'm looking for is C, the cost of the meal before tax. And I know the tax is what? 0.07 what? Remember, percents can't be a loan. C, that is my tax. So if I know the total meal was $16.26, how do I write my equation? This part is just the tax part. So what do I add it to?
The cost.
The cost of the meal, right? The cost of the meal plus the tax is $16.26. Does everybody see that? Okay, you got the cost of something plus the tax, and it equals the cost. Okay, we're looking for what C was. What was the original cost? So 1.07C, 16.26, divide by 1.07, and you get $15.20. That's what the meal cost before tax. Okay. The number of people who signed up for the company picnic and this isn't in your book, this is teacher examples. I'm trying to give you other examples. So the ones that you will not have in your book are this one, this one, all of these were teacher examples. They won't be in your book, so if you want to write them down, that would probably be good. I won't erase them. The number of people who signed up for the company picnic this year is 10% greater than the number who signed up last year. If 253 people signed up this year, how many signed up last year? Okay, we always want to start with our unknowns. So what we're really comparing is this year to last year. We don't know what last year was, that's what we're looking for. But we know this year is 10% greater. So how do I express that? 0.10x. 0.10x. Good. Is that it though? Yes, that is it. Okay. So this year, last year, and 253 signed up this year.
It gives you a decimal.
Yeah, last year.
Okay. So we need to say, this is just the increase, right? This is just the increase. That's not the total amount.
Gives x plus
Yeah.
10
So
x equals
the original amount plus the increase is going to be 253. So it's like a sales tax, because it's a percent problem. Okay, it's 10% more. So this year was actually last year plus that is what we need to do. So this year was the original amount plus 10% increase is 253. When I solve this problem, X becomes 230. Okay, last problem. And this one is not in your book either. Does anybody need to write down the truck rental before I erase it? One salary plan is $30,000 a year. Plus 6% commission on sales. A second plan is $40,000 a year plus 4% commission on sales. At what sales will the two plans pay the same? Okay, so we have Plan 1. How would I write Plan 1's expression?
30,000 plus 0.06.
0.06 what? It could be S. It's
Could be
6%
anything?
of
Okay.
sales. It can be whatever letter you want it to be, though. It has to be, remember, percents have to be with something. Okay. Plan 2 is 40,000 plus 4% of sales. The question says, at what sales will they be the same? So what do you do with them? You set the two plans equal to each other and you solve for S. When you solve for S, so I'm going to say put Plan 1 equal to Plan 2, and S will end up being 500,000. That's a lot of sales to make them equal.
Yeah. So
Okay.
then the better plan would be plan number 2.
Okay, so that's it. That was a long day. Do your homework in MLP 3.1, 3.2. Make a note at the bottom of 191 is some helpful hints. If you're having a hard time with these kind of problems, this gives you some ideas of what you can do. There's extra help in my math lab. There's extra help in the math lab on campus. You can get together with a friend that understands it. You can ask me. So just make sure you're learning this stuff. If you're having a hard time, seek help. And I will see you on Tuesday.